I would like to thank all organizers and all participants of this important meeting. Ladies and gentlemen, it is now time that we as scientists admit that our environment is indeed collapsing at an alarming rate, with billions of dollars of damage already on record for crops and numerous other civilian activity, and the prediction that large cities such as New York, Rome, Seoul, and many other large cities around the world will be uninhabitable within a few years, not within a few decades, during the summertime, with ensuing predictable, alarming civilian upheavals. Ladies and gentlemen, in a situation so serious as this one, with historical implication for the very future of our planet, including the future of our children and grandchildren, it is time to ask the question, who is responsible for this uncontrollable collapse of the environment? The answer, ladies and gentlemen, is one and only one. We as physicists are primarily responsible for the collapsing environment, jointly with other scientific communities such as the chemical, mathematical, and other segments of our science. So the important question to ask, what's the origin of this potentially historical responsibility that all of us individually we are assuming in face of the collapsing of our environment, and vis-a-vis not only the history of science, but also vis-a-vis our descendants? The answer, ladies and gentlemen, in my view, is that we have for 1 century, we have insisted repetitiously in applying for nuclear structure and nuclear processes such as nuclear fusion. We have insisted in assuming without clear experimental verification of the validity under those nuclear conditions of quantum mechanics, in substantial disrespect of the view by Albert Einstein, Boris Podolsky, and Nathan Rosen, who wrote an historical paper in 1935 in which they state that, quote, quantum mechanics is not a complete theory, end of quote. I repeat, quantum mechanics is not a complete theory, which means that quantum mechanics certainly is valid in a beautiful way for the atomic structure, also in view of incontrovertible experimental verification for the condition of the original conception, which are point-like particles under long-range electromagnetic and other interactions. By contrast, nuclear structure are dramatically different than those original conditions of the inception of quantum mechanics. Why? Because according to clear experimental evidence, proton and neutron in a nuclear structure are extended in a very large particles for particle standards of 0.87 FM. Not only are they extended, but according to additional clear experimental evidence, they are in condition of mutual penetration, one inside the others, as established by the fact that nuclear volumes are generally smaller, I repeat, smaller than the sum of the volumes of the proton and neutron constituents, as a result of which those measures establish beyond credible or otherwise academic doubts that proton and neutron in a nuclear structure are in condition of not a point-like particle as studied in a century with ensuing collapsing of the environment. No, they are extended particles in deep mutual entanglement, as also pointed out by Einstein, and others, and many other luminaries of science, and as a result of which there is evidence that cannot be ignored because of the maintaining of our other academic interests, but has to be investigated in detail and resolved experimentally, not theoretically, in one way or another, according to which in the nuclear structure there is the emergence of new forces which are of contact type, proton and neutron penetrating one inside the other. Those are contact zero range interaction, not derived from the potential, and therefore being totally unrepresentable via quantum mechanics. In more deep details, ladies and gentlemen, I respect the view of dissident view, but my personal view is that the Heisenberg uncertainty principle is unquestionably exact for the point-like electron in an atomic structure while moving in vacuum. This is beyond doubt. But however, I simply cannot accept that the same uncertainty principle has to apply for a proton and a neutron inside in the core of a nucleus that is under extremely strong forces, that constrain its location to one specific point, resulting in standard deviation for coordinates and momenta that cannot possibly be the same as those for the little electron in vacuum orbiting around a nucleus. In view of this situation that was already known in the 50s, I dedicated my PhD thesis at the University of Torino, Italy, to the Einstein view of the lack of completion of quantum mechanics. And in particular, I dedicated my thesis to a completion of quantum mechanics in a form which is irreversible over time as a necessary condition for a consistent, otherwise credible representation of nuclear fusion, since nuclear fusion are clearly, notoriously irreversible over time. I then moved to the United States in late 1977. I joined Harvard University on the support from the Department of Energy, and I resumed those original studies, and with the proposal of hadronic mechanics and ensuing comprehensive studies that have been developed over the past 50 years that have recently achieved, thanks to the use of hadronic mechanics, the first known numerically exact and time invariant representation of nuclear data. It has been recently published in a special issue of Ratio Mathematica. The most important implication of these studies for the environment is the prediction that has to be verified experimentally, not theoretically, and resolved in one way or another. I repeat, it's the prediction of the existence of basically new nuclear fusion between light, not heavy, light elements without any possible production of harmful radiation, such as neutronic radiation. And in particular, those are nuclear fusion that generally occur in parts per million, and they're ppms, and therefore they cannot be explosive. Therefore, to having particular interest precisely for the clean production of a much needed electric energy. Ladies and gentlemen, I have also to indicate that during these studies that have essentially over a century, because they were initiated by Einstein in 1935, there has been an accumulation of over an estimated number of 100,000 pages of important research, of which at least 50,000 pages are due to the mathematical, theoretical, and experimental confirmation of Einstein's view that quantum mechanics is not a complete theory. Another 50,000 pages are for the construction and mathematical, theoretical, and experimental studies on hadronic mechanics, and a particular reference to its experimental verification. Ladies and gentlemen, of course, I cannot possibly review even minimally this large effort over 1 century, and therefore, in this lecture, I can only present the summary of our series of reactors that are called Dragon by our technician because they do spit fire. I want to review a series of reactors that we have constructed through the years via private funds, and indicate to interested reader reference on mathematical, theoretical, and physical and chemical research directly related on those new fusion, which, as you can see, they apparently resolve the biggest obstacle against the production of nuclear energy, namely the Coulomb barrier caused by the same positive charge of all natural nuclei, which charge at a distance of 1 FM acquires astronomical repulsive value of the order of hundreds of newtons. Now, keeping in mind that Newton is a macroscopic force, and so therefore it is astronomically large compared to an electron or a proton or a neutron. Well, the studies have culminated in an industrially viable method, systematic and sustainable method to resolve this Coulomb barrier by therefore offering realistic possibility of achieving in due time and with due funding, of resolving all the essentially open problem and achieving indeed the safe, deployable, modular production of new, clean nuclear energy for the production of a much needed electricity. In this paper that I published in 2022 at Progress in Physics. As introductory information, I also recommend a view of this video on the third reactor of hyperfusion that we built, and which illustrates all the various operations as well as the achievement of a sustainability of the fusions themselves. Finally, I recommend also as an introductory information the view of this lecture by Simone Begala Bartoli, delivered an invited lecture delivered at the 2020 International Meeting on DPR Argument, which is particularly significant for interested colleagues because the author is an engineer. As we all know, the biggest difficulty in achieving controllable and sustainable nuclear fusion is given by the so-called Coulomb barrier, which essentially originates from the fact that nuclei in the natural state are positively charged, and so therefore they repel each other, according to the Coulomb law. Now, the problem is magnified by the fact that in order to achieve nuclear fusion, the two nuclei have to be pushed all the way to actual physical contact, which is my conceptual expression of representing the more technical event of activating the strong nuclear forces which are attractive, at which point the fusion is unavoidable. Now, the Coulomb barrier is created by the fact that here, for the case of the attempted fusion of two deuterons into the helium, each having two positive charges, in this case, at the mutual distance of activating the strong nuclear forces, the Coulomb repulsion, which is of the order of 10 to minus 13 centimeter, the Coulomb repulsion has a simply astronomical value of about 1,000 newtons. 1,000 newton. But remember from preceding discussion that the Newton is a macroscopic unit of measure. So when applied to the level at the nuclear level, one can imagine the extreme difficulty in surpassing this Coulomb barrier, and which in my personal view is the primary reason for the lack of achievement of controlled nuclear fusion to date. The main idea of the hyperfusions are all contained in this single slide. The main objective is the engineering, the realization of a new bound state between natural nuclei and ordinary electrons called pseudonuclei. Why so? Because the pseudonuclei will generally have negative charge, by therefore being attracted by ordinary nuclei, and therefore bringing that mutual distance in a very natural way at such a value to activate the strong nuclear forces, at which point nuclear fusions are unavoidable. This main idea is illustrated here by attempting the bound state with an ordinary deuteron, represented here in conventional nuclear symbols, namely illustrating that the deuteron has a single proton, so has a positive charge, atomic mass 2 and spin 1. Then the engineering objective is to bond the deuteron with an electron pair as occurring in a valence bond, because in this case the pair of electrons has a null magnetic moment, and therefore being a pure charge, as a consequence of which it's easier from an engineering viewpoint to bond to an ordinary deuteron. In the event this synthesis can be done in a systematic and controllable way, then the resulting state, called the pseudo-deuteron, has negative charge, but therefore being naturally attracted to ordinary deuteron. This idea is illustrated also by this conceptual rendering. Here on the left, we illustrated the conception of the deuteron according to hadronic mechanics, in which they achieve a representation of the spin 1 of the deuteron via what is called an axial triplet coupling, indicated before. Not only so, but here we also indicate as a necessary premise also the achievement of permanent stability of the neutron when bonded to a proton, which in our view can be easily achieved by decoupling the electrons, the Rutherford electron, so that the orbit is in between the two protons. Once the structure for the conventional deuteron is accepted, then it's very easy to predict the capability of bonding to this structure an electron pair, which is pure charge. First of all, because it is strongly attracted to the deuteron. So the only question remaining being, what is the mean life of this? The state is called the pseudo-deuteron. It is sufficient for engineering application that the main life of this new bond state is of the order of 1 second, because in 1 second, maybe up to 1 million of nuclear fusion can occur. So, but another very important point is for the achievement of the fusion of two deuterons into the helium, is that in view of the electric charge of this pseudo being opposite that of the natural deuteron, there are all the characteristics which are achieved naturally without any engineering participation for the verification of all conservation law. In particular, the spin is naturally opposite to that of the natural deuteron, resulting in a state with spin 0, exactly as occurs in the helium. The same occurs for the magnetic moments, which here is opposite to that of the deuteron, resulting in the virtually ignorable magnetic moment of the deuteron and other conservation laws. So therefore, I can say that hadronic mechanics predicts the synthesis of of a deuteron with a pseudo deuteron in a very natural way, and with the mere release of 2 electrons. A very important point to note is that this state, the pseudo deuteron, is also mathematically represented here and graphically represented here. This bound state of a natural deuteron and 2 electrons is strictly prohibited by quantum mechanics. It is prohibited by the uncertainty principle, because said principle predicts that the electron pairs, they have a velocity of the order of 10 to the 10 meters per second, as can be easily derived for the application of the uncertainty principle in the range of 10 to the minus 13 centimeter. However, if we apply the uncertainty principle of hadronic mechanics, exactly the same speed becomes very close to 0, as we have indicated in preceding transparency. By therefore avoiding the most important and stronger objection against the new idea in the achievement of controlled nuclear fusions. In this transparency, I depict our early effort in the achievement of controlled nuclear fusion, which subsequently became hyperfusion. Main idea was to build what we call a hadronic reactor, which is depicted here. The reason being because it uses the full formulation of Lie admissible mathematics and corresponding Lie admissible mechanics, also called genomathematics and genomechanics, which has to be assumed here on because all processes we are considering are irreversible over time. The objective of the hadronic mechanics was to achieve a controlled nuclear fusion of the deuterium-2 and the carbon-12 into the nitrogen-14 without any possible production of harmful radiation or radioactive waste, without any possibility of producing harmful radiation or radioactive waste, as confirmed numerous times experimentally, because the energy available is immensely insufficient to smash nuclei as a necessary condition for this setup to produce neutronic radiation. As it is well known, the DC electric arc between carbon electrodes is not a continuous arc, because if you look at it at the level of microseconds, it initiates and deactivates continuously to pass from different pairs of points in between the electrodes. So from the genomechanics, we learn that during the phase of activation of the electric arc, we have the ionization of the deuterium gas, and not only that, but the deuterium atoms are automatically polarized into toroids, and then align with opposite direction with corresponding atoms of carbon atoms also polarized under said DC electric arc. Then we have learned that when the arc disconnects, then there is then the pair of so coupled deuterium and carbon atoms are compressed toward the symmetry axiom, with a very mysterious and intriguing phenomena of DC arc, and resulting in here on the structure that we indicate on the right hand side, that we call an elementary magnecule between a toroidally polarized deuterium atoms and the toroidally polarized carbon atom. We were hoping at that stage that this elementary magnecule was indeed sufficient for the achievement of the synthesis, namely that this compression was sufficient to bring the two nuclei at contact with each other, by therefore synthesizing the nitrogen. In this way, the nitrogen. We learn that even though the structure is very important, And for hyperfusion, it was basically insufficient for the achievement of nuclear fusion because of the persistence of the Coulomb barrier in between the indicated nuclei. Here is a quoted paper by Professor Inkazin from Kazakhstan, who identified the threshold for the engineering energy, voltage, and other data for the engineering realization of this, what we call elementary magnitude. Nevertheless, to our great pleasant surprise, we learn via numerous chemical analysis conducted by Oneida Research Services and Laboratories in New York that comparative measurements of the gas contained in the reactor before and after the activation of the DC arc contain a clear, detectable, considerable number of nitrogen nuclei, well above statistical errors, as we will see when we analyze those data later on. So we learn in this way that the electric arc actually, in addition to creating the structure, actually synthesize the pseudo-deuteron in the plasma of the electric arc, which deuteron are naturally attracted to the natural deuteron also in the plasma of the electric arc by producing the helium as a nuclear fusion, in addition to the production of the nuclear fusion between the pseudo-deuteron and natural carbon nuclei that we will see in a moment in numerical analysis. In the top of this slide, I presented the hyperfusion reactor number 1, which is called by the technician Dragon 1, because eventually they did end up spitting fire. And you can see here all the essential ingredients for this first reactor. The hadronic reactor is here. This is the bottle of the deuterium, and this is the AC/DC converter. Again, samples of the gas inside the reactor were taken under the trail of custody by a technician, were taken before the arc, and then after the arc, everything was recorded and shipped to Oneida Research Laboratory in New York for analysis, which clearly indicated the synthesis in considerable numbers, as we shall see, not only of the nitrogen and the deuterium, but also of numerous additional elements that simply did not exist prior to the electric arc. The results of this first hadronic reactor triggered the interest by a considerable number of scientists and physicists interested in independent certification. Here I want to indicate the visit by Professor Ying and his associate from Princeton Gamma Spectroscopy, who came to our laboratory and confirmed with their own measurement, including their own neutron detector, as shown here on the right-hand side, the complete absence of any harmful or neutronic radiation coming out of the reactor. And also they took additional sample of the gas before and after and sent them under their custody to the other laboratory, and they confirm all original statement published in the referee literature. In this slide, I illustrate the first of a series of improvement of the original hadronic reactor. This time it was specifically intended to show the capability of producing steam. And this, of course, was achieved by using a chamber with water as coolant to maintain a constant temperature of the internal reactor chamber. In this slide, I illustrate the third hyperfusion reactor, also called the Dragon 3, that was built according to the mathematics and physical law of the genomathematical and genophysical branch of hadronic mechanics for the representation of irreversible processes. The reactor itself is depicted here on the lower left corner, and it is of horizontal type, and it is surrounded by a chamber intended for maintaining the reactor itself at a constant temperature by using water as a coolant that was continuously recirculated through an outside cooling system. The reactor was powered by a 50 kilowatt power AC-DC converter, as was the case of all other hyperfusion reactors, and it is placed inside a metal container for question of safety. A first objective of the reactor was to prove the synthesis of the silicon-28 from the carbon-12 and the oxygen-16. This objective was obtained in full as established by a number of chemical analysis conducted here for the gaseous state, as well as for the solid state regarding the electrodes, and as we shall see in the numerical part of this lecture. The second primary objective of the reactor was to prove the capability of the technology for a sustainable powering of a steam turbine, which was achieved in full, as shown by this picture here, with the presence of three of our technicians who can testify as of today that indeed that steam turbine could be get operational virtually indefinitely. The objective that was not achieved by this reactor was the capability of achieving nuclear fusion in such an amount to power this time an electric, steam-operated electric generator. This objective was intended for achievement in a subsequent reactor that is now in the process of being built. I should indicate that this reactor was built thanks to $200,000 funding provided from China through the services of Professor Kai from the City College of New York. Unfortunately, this funding could not be renewed because of the advent of the COVID pandemic. Additionally, the construction of the subsequent generation of hyperfusion reactor with the full capability of producing electricity more than that used had to be interrupted because the old tests were done under the US publicly traded company Thunder Fusion Corporation, which had to be sold as a shell while containing the ownership of all intellectual property that now belong to a privately held company called Hadronic Technologies. Let me indicate the most important references on hyperfusions, all available, like any preceding reference during my lecture, with links for free PDF download. Those are some of the originating references of the hyperfusion, which was initially called intermediate control and nuclear fusion prior to the discovery of the pseudo-nuclei. In this transparency, I list all independent certification as well as investigation by various scientists, among which most importantly I should indicate Professor Ying, who is the head of the Princeton Gamma spectroscopy. Finally, and perhaps most importantly, here I list some of the very numerous chemical analysis by independent laboratories on either on the gaseous part of the reactor, or on the solid part of the reactor, or for both. In the numerical analysis that follows, I will use among many, I will use the results, this third analysis, and this is the link to see it in more details. Let us review the certification of the production of excess heat in the synthesis of the nitrogen via Dragon 1, which has been conducted by the physicists of the Princeton Gamma Spectroscopy, headed by Professor Leon Ying. This is the detailed paper that they published, and this is the link for the paper itself, which can be downloaded. As you can see, the paper is dated 2011. The objective was to certify the excess heat via sole measurement of the heat produced by the operation of the reactor. There were two different systems that were used among a number of them. The first was by the use of the deuterium gas as hadronic fuel, in which case the Dragon 1 could only be used up to a maximum of 2 minutes, because after that the heat was excessive for safety of the bystanders. The second system was by using magna gas, namely a gas with a molecular structure indicated early, as a hadronic fuel, and in which case the reactor could only be used for up to 1 minute, at which time the heat produced will become dangerous for the bystander, thus confirming the role of fuel with a molecular structure in nuclear synthesis, an important role which is emphasized by the scientists even in the title of their paper. The results of their in-depth investigation conducted at our plant with their own equipment and their own measurements are the following. First of all, they computed the thermal energy used by the reactor, and which is of 1.333 thermal kilowatt hours. Then they did all the heat measurements for the heat produced in 2 minutes when the deuterium was a hadronic fuel, and they established that the production of heat was about 112 times the original heat used. Then they repeated the same measure by using magna gas as a hadronic fuel, and by this case for measured heat produced in 1 minute end of operation, and concluded that indeed the energy produced in the second case was 355 times the original thermal energy, therefore establishing indeed the production of excess energy over the original used energy. It should be indicated that the above estimate of the excess heat produced by the hadronic reactors is significantly underestimated, because the heat was measured in the outside of the reactor, while in its interior we have a considerably bigger temperature. In fact, the temperature in between the electrodes in the region of hyperfusion, we expect a temperature in the range of 1 million degrees Fahrenheit. This temperature, however, decreases exponentially very rapidly in the range of tens of thousands of degrees Fahrenheit, a few inches away due to the gaseous character of the medium. But in any case, to reach a temperature below the external wall, which is significantly bigger than what measured in the outside. In view of this limitation, the calculation of the efficiency of hadronic reactor via the heat measurement, it appeared insignificant to calculate the produced energy directly from from nuclear fusions which have been detected, identified in numbers via direct analytic measurements. This task is conducted, for instance, with this report from Oneida Research Laboratory, among several that we have seen, and I listed only a few before. In this report, essentially we see 4 columns. The first column provides the atomic mass unit per each species detected in the commercially available deuterium gas that was used. In the second species was exactly the same species, but following exposure to the arc for 2 minutes. In the third column, we have the magna mass as commercially available, and in the fourth column, the same species, but following exposure to the arc for 1 minute. What is already intriguing, because anomalous, is basically the existence of well-identified, numerically identified species with per each and every value of the atomic mass unit, all the way to hundreds. Here I think I stop only to in the range of 110 or so. The energy analysis then conducted by identifying the increase in atomic mass unit of at least some of the most important nuclear fusion reported in this report. And by keeping in mind something very important in a moment, namely that the units are all reported as in parts per million per volume, ppmv. The indicated calculations of efficiency by a direct measurement of energy produced for the most representative nuclear fusions have been published in this recent paper at Progress in Physics, on which you can see the link for its free PDF download. The calculations are based on one or another of the analytic report signed and released by Dr. Rossiter, director of the Oneida Research Laboratory in New York. Again, here is a link of one of them. Unfortunately, it will take me more than one lecture to report in details those calculations. So therefore, I have to regrettably restrict myself just to indicate its main line by referring to the quoted paper for all details. The main objective is to identify the actual number of nuclear fusion for the most representative cases of atomic mass unit. For instance, as an example, here if we look at atomic mass unit 14, which is of course nitrogen, we have 741 number of actual increase per parts per million per volume. And then of course if we go to, and then we similarly have for 16, which is of course oxygen, we have 1,865 increase. And then if we go to 28, which is the silica, we have an increase of 3,687 parts per million per volume. Again, those are only some of the numerous nuclear fusion that occurs all the way to high volume atomic mass unit. Once those numbers have been identified, then we use the tabulated value for their conversion into actual energy produced per individual nuclear fusion, resulting in this way with a total value of energy produced, which is the number of mole n multiplied by 14.628 times 10 to the 5th kilowatt hour. Up to this point, the calculation is fairly accurate, again, because the number of fusions have been experimentally detected, and their value in the energy that they produce is tabulated. So, but what is highly unresolved here is the numeric value of the number of moles for the given hadronic reactor, number 1, the Dragon number 1. The calculations for mole, as it is well known, are rather complex, and therefore they end up to be approximate in any case. The paper here quoted concludes with the lowest estimate that the actual energy produced by the hadronic reactor in 2 minutes of operation by using deuterium as hadronic fuel is of the order of 100 kilowatt hours. This number should be compared with the user energy, which is 40 kilowatt per hour, resulting in this way with an estimate, a conservative estimate of approximately 60 kilowatt hour. By keeping in mind that all those calculations are based on the use of deuterium at only 100 psi pressure, while the reactor had been designed to be all the way to 5,000 psi pressure. For safety, all of us, we decided not to go for this initial measurement over the value of 100 kilowatt hour, also in view of the rapidity with which the reactor will rapidly increase to all the way, in 2 minutes will reach all the way to dangerous level of temperature. And for the case of magna gas as a fuel, it will take 1 minute to reach dangerous level. Therefore, one can imagine the amount of energy that can be produced at 1000 psi of the hadronic fuels. But there is one point which is important for safety that I have to bring to your attention, which is a dramatic difference between hyperfusion and conventional fusion. To my best understanding, in a conventional fusion, those studies until now, there is a virtually instantaneous fusion of a large number of nuclei into a third one by a process that releases instantaneous, such an enormous amount of energy that we all know is very difficult to control. Now, by comparison, the hyperfusion cannot be explosive for the considered low value of the pressure. Why so? Because it occurs in parts per million, and this is ultimately due to the fact that the synthesis of pseudonuclei in the plasma flow of our very special DC arc in between carbon electrodes, that process is at random. In other words, we can statistically calculate the number of pseudonuclei that we can create for a given data, pressure, temperature, density, etc. But we are certain that only part of the natural nuclei are converted to pseudonuclei. As a result of this occurrence, then the ultimate nuclear fusions are limited in number, which is exactly as desired, precisely to avoid a dangerous production of essentially explosive large amount of energy. In closing, I would like to indicate my sincere regrets for my inability to be physically present at this important meeting. Nevertheless, please keep in mind that I am available for Zoom sessions to discuss mathematical, theoretical, physical, chemical, and engineering aspects with any interested colleague with a minimum of 1 day notice. Additionally, I am ready to travel anywhere in the world in the event there are industrialists who invest in research of new avenues for the pursuit of clean energy, because their fortune can be in doubt, maybe beginning from a few years, not a few decades, in the event of the continuation of this alarming decay of our environment. Thank you for your attention.